right, and we're back. All right, I wanted to look at another type of sequence. We already talked about arithmetic sequences. What if I gave you the numbers 2, 4, 8, 16? And I said keep going after that. Well, the fact that it's a whole list of numbers means that it's a sequence, right? But if I wanted to get specific with what kind of sequence it is, I should be looking at the data patterns, the patterns in the data. And maybe you all can see that when I go from one to the other, it's really just multiplying by 2. And that's all well and good. What if the numbers are more intense, like say 3, I'll say for example, 3, 48, 768, and then 12,288. You know what, I'm going to take that one off because it has extra commas. That might be confusing. So I'll just stop here and say it goes on and on and on. Well, this one may not be as obvious to us. So what I wanted to make sure we can do is find a way to find out what the either difference is or whatever. Now, if I look back up here, my example, my original example right up here, maybe I would try to find out if it is arithmetic by trying to do the common difference, right? So if I said 4 minus 2 and then 8 minus 4, and I can keep going, but when I do that, I see that this is 2 and this is 4, so there is no common difference. So this is not arithmetic. All right, since I don't have a common difference right here, it's not arithmetic. So maybe what I can do is try something else. Maybe what happens if I did 4 divided by 2? So 4 divided by 2. And then do the same thing here and the same thing here. Let me see if I actually get something here. So 4 divided by 2 and then 8 divided by 4. And then 16 divided by 8. So when I do that, I get 2. When I do that, I get 2. When I do that, I get 2. Wait a minute, I have another common number here. It's not a common difference because I didn't divide, right? I didn't subtract. It's not a common difference because I didn't subtract. I instead divided. Man, I can't speak right now. All right, let me repeat that. Up here, I tried to subtract, and so I wanted to see if there was a common difference. It didn't work. Down here, I did not subtract. I had to try some other operation. I tried division. Because of that, I don't have a common difference. I have a common ratio. Right? So there's another key phrase, common ratio. Whenever you have a common ratio, you don't have what they call an arithmetic sequence. You have what we call a geometric sequence. Whenever you have a common ratio, you have a geometric sequence. All right, so that's a little bit different. Let's go back down here to our example that I had over here with this bigger number, just to confirm that. Now, I can tell right away that this is not going to give me a common difference. All right, I can't add anything to the same thing to those numbers and get the same thing. So let me at least check to see if it's geometric. So I can do 48 divided by 3, that's this right here. And then I could do 768 divided by 48. Which is this right here. When I do that, I get 16. If you plug that in somewhere, you'll get a 16, and you could go on. But because of that, I see that I have a common ratio. And because I have a common ratio, this thing is geometric. Okay, now, could I find the next number in the list right here? Yes, now I found out what the common ratio is by dividing, but if I wanted to go this way, I would actually multiply by that common ratio, 16. Right? Because as we go from left to right, we're multiplying. As we go the other way, we're dividing. We can use the dividing part to find out what the common ratio is, but then once I know that common ratio, I could just use that to find the other ones. So if I were to actually do that, if I multiplied those things out, then I would get 12,288. So I could find the next item in the sequence by doing that.